After 16 months of testing technologies that can detect the ripples in spacetime known as gravitational waves, the LISA Pathfinder spacecraft shut down on Tuesday, July 18, the Max Planck Institute for Gravitational Physics in Germany announced. LISA Pathfinder, a proof-of-concept mission launched by the European Space Agency, was turned off as planned as its mission came to an end. The spacecraft will continue to circle the Sun in a parking orbit as the agency turns its attention to newer missions. The mission didn't study gravitational waves directly, but instead tested out new technologies for a 2034 follow-up mission, the Laser Interferometer Space Antenna, LISA, which will detect and accurately measure those spacetime ripples. Gallery, the search for gravitational waves. When we were in contact with LISA Pathfinder Tuesday evening for the last time and said goodbye to the satellite, it was a unique and emotional moment, Karsten Dantzmann, Max Planck Institute director and LISA Pathfinder CO investigator, said in a statement. "This mission has been outstanding," said Paul McNamara, LISA Pathfinder project scientist, in a new YouTube video released by ESA. "From the operations to the hardware to the development, it's just been a wonderful mission." The key testing technology on LISA Pathfinder consisted of 2 gold-platinum cubes, each weighing 4.3 pounds, 2 kilograms, and measuring about 1.8 inches, 4.6 centimeters, in diameter. The cubes were suspended inside the spacecraft, and a laser measured the distance between them, nominally 1.5 inches, 3.8 centimeters, for changes in their orientation, distance, and position. "We can determine the distance of the 2 free-falling test masses to less than the diameter of a single atom," Gerhard Heinzel, leader of the Interferometry in Space Research Group at Max Planck, said in a 2016 statement. In 2016, LISA Pathfinder's cubes achieved a near-perfect free fall in space, which demonstrated that scientists could precisely control the cube's positions for future gravitational wave hunts. LISA, slated to launch in 2034, will consist of 3 satellites positioned in a triangle, with each satellite about 1.55 million miles, 2.5 million kilometers, from each other, about 6 times the distance to the Moon. Each spacecraft will have a similar technology to LISA Pathfinder's cubes, called a free-falling mass, nested inside. Gravitational waves will distort the spacecraft's distances to each other by only a trillionth of a meter, requiring precise measurements. Gravitational waves, ripples in spacetime first theorized by Albert Einstein a century ago, are produced by large events in space such as supernova explosions, or the mergers of black holes. Black hole mergers have been detected several times by the Laser Interferometer Gravitational Wave Observatory, LIGO, consortium, which operates detectors in Washington state and Louisiana. However, LIGO and other ground-based detectors can see only some kinds of gravitational waves. It takes a space-based observatory to avoid interference from seismic activity and other distortions on Earth. LISA will detect lower frequency waves than those found by LIGO, focusing on events such as supermassive black hole collisions. "We're looking for the universe vibrating from these mergers, these big events," McNamara added in the video. "It's something you can never, ever do on the ground. So LIGO would never be able to see the events that we see with LISA."